viewers to another video on your G12 mathematics exams. So today our topic of interest is indices. So first question is, what are indices? So indices basically is a group of index. So what is an index? So an index is basically a number which is raised to a power. So for instance, if you have a raised to the power n, the a itself is known as a base, then n is basically a power. So a power basically is telling us how many times should we multiply the base by itself. So if we have such a number as a to the power n, that number is called an index. Then a group of these numbers are what are known as indices. So if you have 2, this 2 is basically raised to the power 1, which is basically equal to 2 itself. Such is an index. So if you have 2 to the power 2, this tells me that I need to multiply 2, the base, by itself how many times? Twice. So I end up with a 4. If you have 3 to the power 2, this tells me that I need to multiply 3 by itself how many times? Twice, to get basically a 9. So basically, this is what an index means. Then, having understood what an index is, let us look at the key principles that we need to know when we are dealing with indices, or what are the key rules. So we're going to briefly look at 13 rules. So the first one, which is the first principle, is basically if we raise any base, in this case a, to the power 0, the answer will always be 1. So example, let a be 10 to the power 0, this is basically 1. Let a be 100 to the power 0 is basically 1. Let a be 77 to the power 0, we end up with 1. Let a be m to the power 0, we end up with 1. So bear in mind, this principle is very important. Principle number 2, which is also foundational principle. So if we raise any base to the power 1, we always end up with that number. So 2 to the power 1, which we looked at, is equal to 2. If you have basically 10 to the power 1, I end up with 10. Then if I have basically x to the power 1, I end up with x. So any number raised to the power 1 is itself. So principle number 3 is about the square root. So if I raise any base to the power half, this implies that I'm looking for the square root of a. So I'm looking for a number that we can multiply itself twice to get a. So for example, if you're talking about 4 to the power half, this is the same as the square root of 4, which is basically positive 2 or negative 2. So what number can you multiply itself twice to get a 4? That's what it implies. Okay, let us move to principle number 4. So principle number 4, basically, if you have a to the power negative 1, then this is the same as 1 over a. 1 over a. So if you have 2 to the power negative 1, we end up with basically 1 over 2. If you have 2 to the power or 3 to the power negative 1, we end up with 1 over 3. So very important, please remember this key principle. Number 5. So if you look at principle number 5, number 5 is about multiplying indices. So if I have a, if the base a, then multiply to the power m, then multiply by a to the power n. Notice that the bases are all a's. If the bases are the same, this is the same as a raised to the power a m plus n. So ideally, we just add the powers. So if you have 2 to the power 2 multiplied by 2 to the power 3, we end up with basically 2 to the power 2 plus 3, which is basically 2 to the power 5. So remember, that is the principle. So principle number 6 is now division of two indices with the same base. So if we have a to the power m divided by a to the power n, this is the same as basically a m a to the power m minus n. So as long as the bases are the same, we can just subtract. Remember, when you're multiplying, you are adding. When you're dividing, you are subtracting the powers. So for example, we have 3 to the power 8, then divide by basically 3 to the power 5. This is the same as 3 to the power 8 minus 5, which gives us 3 to the power 3, which is basically simplified equals to 27. Okay, let us move to principle number 6. So principle number 6, in this case, this is principle number 7. So principle number 7 basically it deals with powers. So if you raise a, the base a to the power m, then again we raise it to the power n. This is basically the same as a raised to the power m multiplied by n. So if you have 2 to the power 3, then again we raise it to the power 2. This is the same as basically 2 to the power 3 multiplied by 2, which is basically equal to 2 to the power 6. Then principle number 8 is about fraction powers. So a to the power m divided by n is the same as basically a raised to the power m, then raised to the power 1 over n, which is the same as basically a to the power 1 over n raised to the power m. So if you have, for example, 4 to the power 3 over 2, this is the same as basically 4 to the power 1 over 2, you multiply by, you raise it to the power 3, which is the same as basically 4 raised to the power 3, then you raise it to the power half. If you notice the first part, this part basically the square root of 4 is either positive or negative 2. So let us in this case go with positive 2. So that 2 you raise it to the power 3, 2 to the power 3, you end up with basically 8. Then if you look at this part, we are going to basically multiply 4 by itself 3 times, we end up with 64. So this 64, we raise it to the power half, we end up with basically 8, because the power half is the square root of 64. So we end up with a positive or negative 8, because so since we are only focusing on the positive number, so the answer will still be a positive 8. Let us just focus on the positive number. Then let us look at principle number 9. So principle number 9 states that if basically we have a to the power negative n, this is nothing but 1 over a to the power n. So if you have 2 to the power negative 3, this is basically the same as 1 over 2 to the power 3, which is 1 over 8 when expanded. So that's what this basically means. If you had 2 to the power negative 2, this would just mean 1 over 2 to the power 2, which is basically 1 over 4. So let's look at principle number 10. So principle number 10 is basically an extension of this. So if we have basically a to the power 1 over n, this is the same as the nth root of a. So if I have 8 to the power 1 over 3, this is basically the cube root of 8, which number can you multiply itself 3 times to give us 8, which is basically equal to 2. So that's about it. Principle number 10. Let us move to principle number 11. So principle number 11 basically deals with if you are multiplying a, b, then this is in bracket relates to the power n. This is basically the same as a to the power n multiplied by b to the power n individually. So if you have 2 multiplied by 3, then we raise it to the power 2. This is the same as 2 to the power 2 multiplied by 3 to the power 2. So if you notice what's in the bracket, 2 multiplied by 3 is 6. You raise to the power 2, we end up with basically 36, because 6 square is 36. Then similarly to the right hand side, to be 2 to the power 2 is a 4, then 3 to the power 2 is a 9. 9 times 4 is basically 36. So still we end up with the same answer. So that's what that implies. Then principle number 12, basically if you have a over b, then to the power n, this is the same as basically a to the power n over b to the power n. So for instance, if you have 2 over 5, then you square this, is the same as 2 square over 5 square, which is basically equal to 4 over 25. So remember this key principle. So principle number 13 is basically, so if you look at principle number 13, is basically an extension to principle number 12, which is a over b raised to the power negative n raised to the power negative n. This is basically equal to b to the power n over a to the power n. So basically these are the key principles that you need to know for you to be able to answer all the questions on indices. So for more exam-based examples, please check on our YouTube channel where we have different exam-based questions on all key topics to make sure that you just get that 100% or at least a distinction.